Okay, so we're going to be solving things using the method of substitution. What types of things are we solving? We're looking at these linear equations here. Okay. These linear equations, you guys are used to solving by graphing. We set up a Cartesian plane, find a y-intercept, a slope, another y-intercept, a slope, and then we find the point where it intersects. The problem with this method is sometimes we'll get points, and let's imagine that the grid is a whole number. We may get lines that intersect in between whole numbers. In other words, we'll get answers that are decimals, fractions, stuff like that, which become very difficult to estimate on a graph. We just have to eyeball it, essentially. So this is where the method of substitution comes into play. This is a much more accurate way to solve points of intersection between two lines. So we have two lines here, or in this case, two equations. We'll number them off here, equation 1 and equation 2. And the goal to this is what we're going to be doing is setting one equation equal to a variable and then subbing that value into another one. And what I mean by that, if we look, we have two variables in each equation. We have a y and an x, and again, a y and an x. In order to solve for two variables, you need to have two equations with each of the variables in it. Okay? So, in our very first example here, they've actually done the work for us. They've set this equation equal to y. Okay? Because they've already set this equal to y, this makes the question a lot easier for us. What we're going to be doing is we're going to be taking the value of y, which is also equal to negative x plus 8. Okay? So what this is saying is that y is the exact same thing as negative x plus 8. So we can use them interchanging. So in our second equation, what we're going to do is we're going to replace the y value with negative x plus 8. So we'll highlight that. This is essentially equal to y, so we can replace y with that exact value. So we're going to go into equation 2 and replace the y with this value. So now equation 2 is going to read x minus negative x. And actually, you know, I'll do that in red so you guys can make the distinction now. Minus negative x plus 8 is equal to 4. So the part I've written in black is the same as the equation above, but the part we've written in red is the new thing. So the x minus and the equals 4 are the same, but our y value has been replaced by x minus 8. And the reason we're able to do that is because we know y is equal to that. So we can replace that y value with that number. From there, we're going to solve. We only have one variable left, so we're going to solve for the variable x. We're going to need to distribute this negative sign to both of the terms. So we're going to get x. Negative 1 times negative x is positive x. Negative 1 times 8 is negative 8, is equal to 4. X plus x will give us 2x. Minus 8 is equal to 4. We'll then move the 8 to the other side of the equation because the goal is to solve for our variable x. We'll get 2x is equal to 4 plus 8, and it goes over. 4 plus 8 is 12, so 2x is equal to 12. Then, to isolate x, because it's 2 times x, we need to divide both sides of the equation by 2. We're going to end up with x is equal to 6. That's great. We've solved for one of the variables. So this is one of our final answers. We know that x, yep.
I'm just wondering, how did you get plus at the top, like the second equation?
Here?
No, like the one like after that one. Yeah, how did you get that one?
This is like a negative 1. So we're distributing negative 1 to each of these terms.
Oh, all right.
Okay? So negative 1 times negative x gives us positive x. Does that make sense? Okay, so now that we have this x value is equal to 6, what we then need to do is take that value and plug it into one of the original equations. And we'll bring both of those up so you can see them. The original equations are either y equals negative x plus 8 or x minus y equals 4. Once I have the value for one of these, I can plug it into either of the equations for that x value. And then I'll be able to solve for the y. Prior to that, though, remember what we did is we took the value of the first equation and we had to plug it into the second one. we would not have been able to replace y with this value if we plugged it back into the same equation. So, we cap that. The very first step, we set it equal to a variable and then plug it into the other equation. Once I have the value of a variable, it doesn't really matter. I can plug it into either. To make things simple, I'm going to plug it back into equation 1. So we'll zoom in again. Okay. So our value for x was 6, right? Yeah. Okay. So we're going to take that original equation again, equation 1, which is y is equal to negative x plus 8. And we know x is 6. So we're going to place the x with the number 6. Oh, sorry. Thank you. There you go. That's an 8. So we're going to replace this x with 6 now. So we'll get y is equal to negative 6 plus 8. What is negative 6 plus 8? 2. And that's it. We've now solved this equation using substitution. We have an answer x is equal to 6 and another answer y is equal to 2. And what that means in terms of graphing, okay, again, this happened to be nice round numbers, but these two lines are going to intersect each other at the coordinate of 6 and 2. That's our x value and that's our y value. So if we graph these, we find that they would intersect each other at that point.